Good morning, guys. I'm going to apologize up front. This is going to be a lot of written notes today, but it's a lot of definitions and things that we need to understand. So let's get started. We're going to talk about a polynomial. So in math speak, when you're going to read it out of a book, it is going to tell you that it is an algebraic expression that can be written of the form a sub n x to the nth plus a sub n minus 1 x to the n minus 1 plus, and it would go through all of them in between to a sub 2 x squared plus a sub 1 x1 plus a sub 0. Okay, so that's a lot of math speak just to tell you that it's going to run down in order, largest exponent first, down to the term that would not have an x or have a variable, which is called my constant term. And they're just telling you that n is non-negative, so any of these n's are non-negative. So we're not going to have a negative exponent anywhere. We're not going to have a term, or a constant term, or a coefficient that would be odd. Not odd as in odd number, but just off, not normal, not positive, okay, or negative, but or a whole number or something. X is a variable, and a sub 0, a sub 1, a sub 2, and all of those in front are called constants. Okay, they're all going to be constant. They're going to be a number of some type. They're called the coefficients, and your a sub 0 is called your constant term. All right, so what this is all trying to tell you is for it to be a polynomial, okay, all your exponents have to be whole numbers. That means there's no variables as exponents, no fractions as exponents, no decimals as exponents. Okay, no variables are in the denominator. So if I have a fraction and a variable's in a denominator, it's no longer a polynomial. No variables are under a radical. So if I have a radical of any type, a square root, a cube root, fourth root, doesn't matter if there's a variable underneath of it. It is not a polynomial. Okay, so maybe not this part, but these, what they can't have, okay? And just say a polynomial can't have and write that down. So here are some examples, so let's go through some of them. When I look at this one, is it a polynomial? Well, I have a variable. No variables are underneath a radical. No variables are underneath a fraction. Then I look at my exponents. There are no variables in my exponents. There are no fractions in my exponent. There are no decimals in my exponent. So we'll stick with you. Yes, this is a polynomial. All right, so let's move on over here. This is negative 12 to the x power. There is not a variable under a fraction, not a variable under a radical, but my exponent is a variable. So no, that's not a polynomial. If I come over here, I have y to the 17th plus y to the 12th plus 3. Again, no variable in my denominator, no variable in my under a radical. My exponents are all numbers. There are no fractions, no decimals, no variables. So yes, that is a polynomial. This one here, here's the problem. I have a variable underneath a radical, so this is no. This is not a polynomial. When I come over here, there's a decimal, but it's not an exponent, so yes, that is a polynomial. And this last one here, notice how my variable is underneath in the bottom in my denominator, so no, that's not a polynomial. All right, so that's just a quick recap of where it would look like. So when you only have a constant, so maybe it's just a 3, just a 4, negative 2, whatever, all right, it's called a constant polynomial. All right, it's still a polynomial even though there aren't any variables. It's a constant polynomial. The degree of a polynomial is the largest exponent. The leading coefficient is the coefficient of the variable with the largest exponent, or the first one when written in order. All right, so let's go over these terms. I don't have a constant polynomial here, but if I'm looking at this equation here, first of all, is it a polynomial? And the answer is yes. Okay, it is a polynomial. Okay. What is the degree of the polynomial? So when I look at this, I notice my exponents are in order from largest to smallest. The largest being 3, so my degree is 3. And then my leading coefficient goes with that one. So again, since they're in order, we go to the first one. My leading coefficient would be 7. Okay, and that's the terms that we used above, so please make sure that you copy these down and have those so you know where to find them. Oops, did I skip? Yep, I skipped the page. So there are some special names for polynomials. All right, so we have a first degree is a linear function, a second degree is a quadratic function, third degree is called a cubic function, and fourth degree is called a quartic function. These are the special names. After that, it's just a polynomial function. We don't give it a specific name. Okay, take these down. All right, so, and the last thing here says, is it a polynomial? If so, state its degree. No, that should be its. Let's fix that. Apologize for that mistake. State its degree, leading coefficient, and constant term. All right, so we're looking at this first one here. And again, I noticed they run down in order, which is helpful. So is it a polynomial? So the answer to the first one is yes, it is a polynomial. Okay, so yes on the polynomial. So since it is a polynomial, I want to know its degree. So I want to know its degree, leading coefficient, and constant term. The degree is the largest variable, and that is 3. Leading coefficient goes with that one, so it's 6. And my constant term is a -2. Okay, now let's look at this one. Again, looking at it, they go down in order. Is it a polynomial? It looks like it would be, but when we get to this part here, notice how my variable's in the denominator. So not a polynomial. Okay, and that's just how we're going to tell the difference. If you need help with anything, always join our Google Meets during class time. Can ask me if you do have an in-person day. You can join me at ASA after school on Mondays and Tuesdays from 2:30 to 3:30, or with Mr. Parks on Wednesdays and Thursdays from the same time. All of those are in your Google Classroom. Have a good week, guys.